today's interview. Patrice Roy, you wrote a book about C++ memory management. That's really nice, but let's start with an introduction. What does Patrice Roy do with C++?
Okay, so that's fine. I've been a professor for 28 years now, both in college and university. C++ is my main tool to teach stuff. I also use other languages, but that's my main the main facility with which I teach stuff. I work with graduate students quite a bit. Lots of video game programmers and people from the low latency fields. I do real-time systems. My background was in military flight simulators before I went to academia. So I've been involved in the C++ Senders Committee for 10 years now, and most of the work I do is tied to SG14, which is obviously the low latency study group. So this is what I guess, mostly known for. The book itself was a suggestion from my editor who came to me and said, you've been giving this CPP in class quite a bit, memory management with C++. Would you like to turn that class into a book? I said, well, I've never done that, so why not? And you know what? It's quite different from giving class. So it was an interesting experience. I'm glad that I've done that. So I hope that answers your question, Ryan.
Yes, that's, I think it's so. One of the ways I got to meet you was at conferences, and we're hanging out at CPPCon. And yeah, I thought I know a bit of your background that, was writing a book was an easy task for you with all the years of experience of teaching. And so that's why I think that a lot of valuable knowledge in this book is in there. And I think first, let's have a quick overview about the book itself. So I will bring it up. And there's a preprint version. That's why I can't show you the title page, but you see that in the images for the events, right? So let me go into, and let's quickly go through the index to show you what the book is about, the table of contents. So the book has 4 parts, and this is the first part, memory in C++. You may think this is very basic, which is true, but it's also very detailed knowledge where Patrice shows his knowledge about how things basically work in the machine of C++.
Yeah, it's basic, but I don't think the people who really know that stuff are very few and far between. I'm lucky that I've been involved in the core working group for 10 years now, those who write this thing. And even then, I'm hoping that I didn't make any mistakes there, but there's some deep stuff. And there's stuff that is moving a bit these days. We're sometimes rethinking things in C++. We changed the meaning of the restrictions tied to integers just recently. So this is not a language that stopped moving. We're trying to do things better. The very idea of a byte, say, is currently at least 8 bits, something that is big enough to hold a Unicode character or something like that. I don't remember the exact words. But that might stabilize on exactly 8 bits sometime in the future. There's discussions about this. So there are moving targets there, and sometimes very, very subtle. I wanted to make sure that we had a common vocabulary and a common understanding of some of the basic and essential concepts before you start working. So that's why I wrote this first section. And you might notice, especially with the page that you're looking at right now, chapter 2, it's filled of stuff you shouldn't do. And I felt kind of weird writing a chapter like this, like, don't do this, please. But my point was, in this book, by definition, we sometimes have to get our hands dirty and go low level a bit. So I wanted to make sure that if we did that right. So not trying to do things you're not supposed to do because it kind of works. Maybe C lets it go. Maybe your compiler lets it fly because C does it, but it's not correct and don't do that. So I wanted to make sure that we had a common understanding of that too before going further. So I'm hoping people don't get rebuked by this when they read the book. It's kind of weird to start the book with "Don't do this," but hopefully it will help people get finer standing on what they're trying to do and how to do things, and
Mhm.
be able to make their way through the book better after that. That's my hope.
I do think that it's something which really makes the book really good. So I was just intrigued by the special cases of char and STD byte. And STD byte is something which is rather new in the standard, and a lot of people probably have no idea what it is or how to use it. And so it's like also kind of, uh, memory management gets interesting when you get to be on the low level. And so it's really nice to see that you establish this lower
Thank you.
line things.
Well, but
Um,
Byte is a C++ 17 feature, STD Byte, and it was controversial when it came out because if you go back to before C++ 17, the
yeah.
word byte, when you saw it appear in C++ code, it usually came from platform headers like Windows.h or
Mhm.
the Unix stuff. And it was an alias for, let's say, unsigned car or something like that. So you ended up with a type that you could do arithmetic on. And now SED byte, you can do bitwise operations with it. You can cast it to an integer because it's an enum built on some kind of unsigned car, but you cannot do arithmetic based on it. So people were reacting strangely, saying, "This is not the byte I'm used to." But it was a byte designed to do specific things. We want to, at some point, retire car from its role of being a byte and use something else. But we're not there yet. It's going to take a while, but we're going there smoothly. But in my book, I mostly use car. I think people are more used to car than signed car than to byte.
Yeah. But let's move on from the basics. There's actually part two,
Mhm.
um, implicit memory management techniques, which starts with, covering destructors as I see and introducing RAI and also going into the smart pointers and the, lookout, scope card discover. This is uh, the things which are the basics of what you're then later building upon. So this
Yeah,
kind of continues what you did in the first part.
absolutely.
And
If you're writing C++ code today, you should be striving for those tools mostly. You don't want to do manual memory management if you can avoid it. You want your files to close themselves. You want your memory to release itself. You want to know who's responsible for your data and your code. So you want to know who's the owner or what are the semantics tied to that. I think it's cool. When I use other languages sometimes and I need to close files manually, I feel awkward doing that in 2025. So I'm hoping that this section of the book
mm,
is accessible because you will find there things I think most everyone should know how to do or should know they should do when writing C++ code. Maybe take aside the issue of writing smart pointers that might not be for everyone, but at least using them right is probably to everyone's advantage.
well, let's take a look at writing.
Thank you.
Um, I have to say that like implementing or basically showing the implementation of those smart pointers is probably also very interestingly
Thank you.
for people to just who don't want to write their own, but to understand basically how do they work. Like how does unique pointer actually work, and how does it what are the mechanics of that?
Well,
And
it's one possible implementation because your standard library writers do a very good job, and please use their stuff. But writing one yourself, at least you get a better idea of what's going on there. Yeah.
I am certain that when you would cover the fully implementation details of the standard, your book would be a lot longer. But I think
Yeah. Well, I'm
your
not planning to replace my library writers. They are very, very good. I'm not trying to encourage knowledge, but please, the standard tools are awesome, so use them.
but like here we go into shared pointer, which
Yeah.
that's then also getting a bit more complicated than what basically a simple and that's like this even the simple version of a unique pointer was a few pages and um,
Well, shared pointers are very tricky, but they're done right in the standard. The thing that people have to grasp when they're trying to write this sort of stuff is, when you're told in school that there's these solid principles in object-oriented programming, and S is single responsibility. A shared pointer, by definition, has two responsibilities. That makes it intrinsically tricky to write. So I tried to give what is in the book works. It's usable, but of course, it's nowhere near as sophisticated as the real stuff is. But it is
Mhm.
enlightening, I think, because I've heard people tell me that seems simple. Wait until you try to write it for real. That's fun.
Mhm. Well, then we get to the third part, um,
Okay.
which
That's more technical, yeah.
yes, where actually where the content of the book at page 130 actually starts when you want to implement your own versions of like um,
New and delete and stuff like that. Yeah.
yes, and I think that's again that's like there's before we started the interview, I told that I told you that I think that's like the thing about memory management, which can be frustrating in C++, is that we are already pretty good with it, and so doing it correctly and being faster in the situation you'd like to apply it to can be difficult, or like just pick a library that has an arena allocator, which I see you have here arena based memory management and other optimizations in a chapter. Um, and for leak detection, we have tools for that. But of course, basically understanding how those tools work is again very valuable. Um,
The C++ is about control, you know. So the crowd I work for normally, my game programmers, my finances people, my embedded systems people,
oh, sure.
they need control over what they're doing. So in these chapters, what I'm trying to show is that sometimes when you know what the context is, you know how your code will behave. You know maybe how many objects you will create at worst. So you know this kind of stuff. Well, you can
Mhm.
indeed do better than a default solution because allocation is not something that accepts a general best solution. That's not how it works. There's some very good average solutions. Your libraries provide very good stuff like already. But when you know what's going on, you can always do a bit better because you can use that special knowledge that you have. So these chapters show that you can, if you do that, measure it. And
Yeah,
we actually kill orcs there. So if you're a Lord of the Rings person, we're killing orcs in this like
yeah,
enemies in the
also a nice touch. Um, and then we get into writing containers. And today I actually read through the vector example, where you show basically how basically a vector works, and you also implement a forward list here. So you're kind of staying into contiguous containers and not implementing a map or something like that. But yeah, implementing containers is, I think, an interesting topic when you start writing memory managed code, right? That's a different form of memory management.
my understanding is that when you go to school and you try to learn writing stuff, you can write a correct container that works fine for, let's say, integers or floats and doubles. It's going to be efficient enough. It's going to be cool. When you want to manage objects that are non-trivial, things that have destructors that do work and constructors that do work, if you measure the speed of your naive code, compare it with the CD vector, you're going to see that the CD vector is crazy fast because it does a very tight, it has very tight control over memory management and when things are created, destroyed, and everything. So we start with the naive stuff you might know about, and then we see why it's not as fast as you might like it to be, and then we see what you need to do to get there. So this is technical, of course, but I hope it's enlightening. And it makes you appreciate your container writers in the standard library because they actually did that job for you.
Of course, yeah.
But yes, knowing how it works makes a difference if you need that kind of speed and control. I know that my games people they tend to write their own containers for various reasons: integration with their own engines, historical reasons, the way their code base works, and everything.
Yeah, I think
So
that's
I yeah
not everyone has a standard library or wants to use a
no
standard library, because the standard
absolutely
library absolutely does do compromises. So it's not always the fastest or the way you want to have control. And we're
you're
not very
absolutely right.
good in offering the kind of access, especially in the legacy containers and legacy code, like, containers and algorithms are, they're not legacy, but they are very old in C++. And so if we wanted to add something to vector which would break the ABI, you would never see that. And so,
Absolutely, absolutely. So yes, so yeah, you can do it. I think is useful. The reason I put forward list there because you're mentioning it is not that I'm encouraging forward list. I wanted to have a node-based container in there too, and I wanted something simple because I go in large detail over
yeah,
continuous memory because I think that's the gist of what most people reading this book will want to know about. But nodes have their own peculiarities, especially when it comes to containers with allocators. So I wanted to have at least one to be able to discuss those things with people. So that's why you have two kinds of containers that are
mhm.
different in the way they behave, so that I could and go on explaining both kinds of perspectives of memory management.
Yeah, and then like part 4 continues here, and we see like, you mentioned polymorphic memory resource allocators, which is also historically still a new feature,
Mhm.
even if it's now, available for some time. Um, and then you have a chapter on contemporary issues, and then you have a lot of things which are important and people should know about in the annexure. So that's something which is like at the end of the book, but you definitely should take a look at it. So
Yeah, yeah.
let,
I was telling you before we started officially doing this that the when I started writing the book, starting writing the first chapter, I realized how many things people have to know to actually get into the book, and most everyone will know a large part of it, but I doubt that everyone will know all of what they need to know. So I was looking for a way to make that information available. Those
yeah,
things that if you don't know them, you won't appreciate the book as much, and put them together somewhere. So that if you're seeing the book discusses traits, you don't know what traits are, you can go there, get the
hmm
gist of it, the idea, see some examples. I'll say, okay, I get what's going on there. I'll be able to understand what the book's talking about.
yeah. I think
And it,
that's really a nice touch
thank you.
to
Uh,
to have those basics covered, because that's also often something which people can look up on the internet too. But um, so um,
I'm hoping it
overall,
helps. The contemporary issues chapter is a bit shorter than the others because it's stuff that is either in the standard but not implemented by anyone yet, as far as I know, or will be in the standard in some form soon. It happens that some of the aspects are like trivial relocation. We just voted it in the February meeting of the C++ standard. So now we know what form is going to take essentially. But when I wrote the chapter, I was almost sure where it was going, but we still had competing proposals. So these are things that you will have to read more on to really know what's going on, but at least you'll know it's there.
I've just looked at trivial relocation, and that's really interesting to look into. And know that I could like potentially talk with you about it, because there's like a lot of different views on this, and I stumbled upon that because I was basically getting interested what's like new on like class, and I knew that you could say that a class is final, and I was like, wait a minute, why there's two new things coming in 26 that you can say, and these are like really long and weird names. I was like, what is this? I never heard about it. And so, and then if you follow the trail, you stumble into relocation and trivial relocation and relocatability. Uh, KDAB has a 5-part series on its
Cool.
blog. I definitely think is a good read about it. Um, but I stopped like doing like my research on that because it's very broad and very complex topic at the moment.
Yeah, but what you want to know is that some types, we have copy, we've had copy semantics for a long while. We've had move semantics for almost 15 years now, which is awesome. I mean, when you went into C++11, you recompiled your old code, changed nothing, it just went faster right away because move kicks in. Well, with relocatability, for those types, for which a mem copy or a mem move followed by a destructor is sufficient to do the job. Vector and such will be even faster with C++26. So we'll hit again a mark where you just recompile your code with your newer compiler, you change nothing, and then it's faster than it used to be. So this is kind of awesome. We had two competing proposals. One was attribute based, and the other one was keyword based. And there was a
Mhm.
fight to the end. Both were interesting. We ended up with the keyword based thing. There were upsides and downsides to both, but the important thing is that we have the feature now. So we have to thank all of those who worked on both sides of that fence to get us there because we've been working for a long while on this. And I remember having corridor discussions in 2017 about this with people. So it took 10 years to come up. So yeah, we're all very happy that we get that. It's an important optimization feature.
Yeah, and I'm not sure that Saga is over yet. So the next standards proposals meeting in summer
Absolutely.
in Bulgaria will be interesting. But anyways, let's get into the questions.
Hmm.
Um, so let's start with something easy and what probably interested by the audience, right? Like, what is the audience you envision to be interested in this book?
Whenever I have to give a talk or something, and I'm asked that question because people want to know is this thing for me. I tend to write like intermediate to advanced programmers. I think okay. So if you're a C++ person who wants to know more about how memory works and how you can write your own tools, of course this is for you. That goes without saying. You might find it crunchy at some points, but I am hoping that you can read through this thing. It's been carefully written to get you to understand stuff, and I tried to make it fun to read, even though it's a bit dry sometimes. I don't think it's right in the way it's written, but the topics, it's not something that you want to tackle on your own if you can avoid it. I think people coming from other languages, the people that have garbage collected stuff normally and are wondering how do these things work? Could it be more efficient or something like that? I want to understand more what I'm doing because my usual languages, even though I like them, they hide stuff from me and I want to know how it works. I think they might like this book too. We had a section there on different reclamation, which is not garbage collection, but it's kind of like that to give points where your objects will be collected as a group. That can be more efficient sometimes if you collect stuff as a whole instead of piece by piece. Maybe it's more efficient sometimes. So you can have an inkling of how you can do this thing if you're interested. So I'm hoping that these people will get something from it too. The key point probably about C++ is controls. People who use C++, they're willing to use this thing that is reputedly a bit harder than other languages, although I disagree. I kind of find it beautiful myself because they want control over what's going on. So if this is what you want to get, if you want to make smaller objects and faster code, know how to align stuff to benefit from the cache of your machine or things like that, I think this book will help you get to where you want to go.
Mm-hmm. Yeah, I have this impression too. So we already touched a bit on standardization. So, like, what is the standard you use in the book?
That's a tricky. I asked a question earlier when we were discussing offline, and I would say C++20. I let bits of C++23 here and there because I'm using STD print sometimes, which is a replacement for
Mhm.
C out now. The people will like, I think. So, but if you don't use C++23, the bits that are C++23 related are easy to like move aside.
Mhm.
But they do make for cleaner examples. There in the allocator section, I go more on an historical direction, where allocators have changed quite a bit from before C++11 to from C++11 to 17, say, to today. So, and I try to give a historical perspective on how things evolved, why they were the way they were, why they are simpler today, and what you gain from it, and give examples at each step such that you have a working example depending on how what standard you're using in your own code base. So I'm hoping that will make people will understand how allocators work a bit better. because it's a tricky subject. So I would say, generally speaking, C++20 with bits of 23, but for some simple stuff, with sometimes a look a way back to get a broader perspective on things.
Mhm. Um, Now, writing so many pages about C++, what did you learn about C++ while writing the book?
Well, I learn about C++ every day, I think, because this is such a cool language. I think there's only one person who knows the whole of C++, it's Richard Smith at Clang, who's just incredibly proficient with this. Even Bjarne, I think, doesn't know all of C++ these days. I sure don't. But the when I was writing the allocator section, I think to write the old code, today's code, and almost the code for tomorrow, seeing how things have evolved was enlightening to me. You know, there's things that I use in classes, in my own classes when I'm teaching. We do the basic stuff, we make it work, that's cool. But when you really want to delve into it and make all the nooks and crannies work, uh, using unique pointers or manual memory management and everything, there's quite a lot of interesting things that you need to do to make it work. And I found that enlightening for myself. I was glad to put that on paper. I don't know about you, my friend, but uh, allocators in particular, there's not that much information online to help people know how this thing works, why you use them, how you use them, what are the pitfalls. I don't know if I did a good job, but I really tried to, with this book, put that kind of information in the hands of people because when I look for it, I don't find it myself. So I'm hoping people will like that because I know it was interesting for me to write and test. And of course, if someone finds a bug, please write to me. But I had very good technical reviewers that helped me find the bugs up front. So I think the book's probably stable now.
Yeah, I've been playing around with PMR allocators last year too, to just see, to get a feeling like, does it work for me? Or like, is it like, and anyways, how do they work? Because it's like so much is still new in C++ when you're not like every day learning C++. Um, and we do actually, regarding that, have an audience question.
Oh, cool.
Slightly off topic, but I think it's actually pretty much on topic when we talk about memory management. Um, do we have any improvements to memory management in the standard library past C++ 17, so 2023, 26?
Of course we do, but there's too many to speak of. It depends on where you put the goalpost there. Okay, so the if you look at the automation of memory management, like using smart pointers, your own containers, and everything, the world continues to advance and evolve. We have new containers. We just voted Hive in the C++ standard for C++ 26. So that does the definition for you underneath the covers. That's cool. We still spoke about trivial relocation a few seconds ago, so that changed things. C++20 has something called destructive delete that you will find in the book, which is interesting. When you write operator delete normally, that operator intervenes after the object has been destroyed to free memory. But there might be cases, and there are some cases discussed in the book, where maybe you could do better if delete was asked to destroy the object as well as restoring memory, because sometimes you can avoid virtual calls and things like that. There's some optimizations you can do in niche cases, but these cases they exist. In the recent issues or contemporary issues section, you will find something by Louis Dion, who's working on the Clang library these days, and who's trying to harden the library and has found that in some cases, operator new that normally comes in before construction happens to allocate memory. Well, sometimes if it knows what object it's going to construct, it can do something better too. So we're still rethinking the basic fundamental tools we're using because sometimes we can do better. So yes, we're still trying to make the library better as well as the language better, of course. And if I may, everything that is tied to memory it, it as it's like an octopi. It touches every part of the language in a sense.
Yeah.
So it kind of interacts with concurrency. It interacts with a number of other things in the language, and all these things are moving. We have new abstractions in each of these cases, and they interact interestingly. So yes, it's. I hope you don't stop looking for the way C++ improves. It improves quite a bit. And C++ 26 is going to be a big standard.
Yeah, right. I'll get back to the audience questions in a minute, but I think
Cool.
there's so wait, I gotta so yeah, we had that question. Um, when you write such a complex book, naturally errors occur, and so
Absolutely.
um, is there anything you would like to change in the print version, but now it's like printed, and do you know about any errors?
Not yet, but I'm sure there will be, and of course they're all my fault. I continue though that because I find it interesting from a teaching perspective. Um, Writing a book is very different from giving a class because you don't see the faces of the people reading the book in front of you when you're working. So you have to make sure everything is as clear as you can up front because while they're reading it asynchronously from when you're writing it. The reviewers sometimes reacted to things based on their own beliefs of how things worked. I think that helped me discussing with them, see why they saw things differently. I think what the book was saying was correct, and I think they agree with me now. But that forced me to rethink the way I presented stuff to make things more interesting and more clear for them. In some cases, they suggested very good examples that I could add to enrich the discourse and make things clearer. So I know that I don't know if we could call them errors. There were a few errors here and there, of course, but I think the book is better due to the contribution of those very good reviewers that I had that make good suggestions, challenged me to be
Yeah,
clearer on the way I said things. And of course, if anyone has new stuff to say about the book, you can just write to me and I'll be happy to read about it. And maybe if there's a second version, it's going to be better. But I think that due to this extraordinary help I've got from my reviewers, I think the book sure has its flaws, but I think it's a good book.
and there's always some things which might change, or but
Yeah.
when you already it's based on your courses which you have given for some while, so there is probably had been some time to iron those out. That's really interesting to know. Let me return to the audience questions. There's some really interesting ones.
Oh, cool.
So Shouted Mojave asks, "Hi, why does STD Vector not use the hint version of allocator allocate? This would come in handy when dealing with virtual memory extension mechanisms."
Yeah. Well, so the easy answer to this, Farid, is you don't know what Victor does because it's up to the vendor to use or not those hints. To really use the hints, you have to have an allocator that is maybe tighter, more tightly bound to your container, such that you kind of know what the hint means and where to go with it. So that argument to the function is not often used. I don't think it will be used much in standard containers because you could use any allocators with them and you don't really know if they're going to behave. If you are writing your own container and you know what you're doing and you know your own allocators, then this interaction you can try to use to bring better results. So that might be even one reason why you might sometimes want to write your own, because since you know what your allocator, how your allocator will provide the hint and what it's there for, your own vector could benefit from it more than the standard library could, as it doesn't really know what your allocator is trying to say. Is that okay?
Yeah, I
So
think that's a good
i-
answer.
if
Um,
I mean vector is a specification that's implemented by many people. Let's put it this way. Cool.
um, David Bellis asks, "Sharing memory between processes on Windows and Linux requires using libraries specific to the operating system. Are there any data structures in the SDL to help manage the objects stored in shared memory?"
That's a beautiful question. So the short answer is no, but the good answer is there's a way to do that, and we discuss that in the book too. So C++ itself is silent on the issue of shared memory. It's not something the standard discusses. So that's why you won't see tools for that in the standard library per se. But there you can write overloads of operator new and delete that interact with classes that you write yourself, and you can make these classes communicate with your operating system. Actually, I have an example in the book that simulates that with multi-threading instead of multiprocessing, just to make things more portable. So yes, if you write a class that represents that shared memory and maps allocation functions to what your operating system does, you have, or you can write overloads on new and delete that interact with that class and make it almost seamless to allocate and deallocate through shared memory in standard C++. So you can do that, but the standard library won't do this for you because, as I said, the standard is mute on that topic.
And then we have a question which goes, Andrew Cuff asks, what teaching platforms would you suggest for developing embedded C++ while teaching or for teaching in the
That, that,
context?
that's a good question. I normally use standard compilers for that and do cross compilation if I need to. I know that my friend Dan Sachs, who taught that quite a bit, had his own tool set for that. Ben Sachs, his son, is in the standard with us. I think he has his own tools for that. I don't really just cross compile from a standard compiler, really, to be honest. So I'm sorry I don't have a good answer for you for this. If I may, though, if you're doing this, you might want to watch for the freestanding stuff we're doing these days. We're trying to clarify what freestanding implementations are supposed to support. So maybe that can guide you and at least your choice of libraries and compiler options. Even if it doesn't change the platform you're using, it can still influence your tools to make sure your code will work on those platforms.
All right. Let's get back to look, thank you for your questions. Generally, we're open to more. But while we are teaching, I think let's quickly, go to another popular topic these days. How do you see the rise of AI for coding?
So from a teaching perspective, this is very annoying. But because you never know if your student wrote the code or if it was produced for them. But so this is a question that has layers, I think. Okay, so if you're working with beginners, the problem with AI is that it gets in the way of learning a bit. So it produces answers. Sometimes you just press tab, tab, tab. They get code. It sometimes works, sometimes doesn't. They don't know why. So for beginners, it's kind of an annoyance more than something. Uh, Students that get better a bit, they can use that to get more to produce code maybe more quickly. But I'm hoping that when they start using those tools, it's because they kind of understand what's being produced. Because my worry is imputability. If you're producing code, it's your code, you're responsible for what you wrote, you have to understand what you did. So to me, AI is more interesting with experienced people who know what they're doing and want to save some time, maybe, or get some insights on a problem they're having a hard time with. But they have to be able to say at the end, I'm confident in what they produced there, and I think it's okay. Even though I didn't write all of it, I can attest that it's correct. I don't think beginners can really do that. From a teaching perspective, the other problem with this is that it's making writing practical exams more difficult because it's harder to know what you're evaluating. So we have to go back a bit and do like more exams on paper, stuff like that, to make sure that we evaluate people in an isolated setting to know what they get, what they're understanding. If someone were telling me at this point, well, in real life they will be using AI tools to produce code, I would answer yes, but you wouldn't hire them if they didn't do anything. You will hire them when they're proficient and you make them better with AI. So you won't hire them saying, well, they're going to be using AI to produce code anyway, so I don't care where they come from. That's not what you're going to do. So that would be my take for now. In a general teaching setting, because I'm a professor, I was discussing that just before our interview with other people. It poses a lot of problems. Like, is this text coming from a student? Is it an actual quote from someone? Is it correct to quote from an AI text? Sometimes it's very good. Why not say so? So there's good and bad about this. But from a programming perspective, I prefer it when experienced students use that to be better than when starting students are trying not to do the work.
Yeah, I do think that it still will take some time to like see the full impact of what the tools are actually doing socially, and also kind of um, one interesting thing I've seen earlier this year is like in code analysis of GitHub profiles on like GitHub projects. And they showed like that basically since the release of ChatGPT, you clearly see an increase in code duplication. So, and that's not like a sign of quality usually, right? So, and it's like um, one thing that in the last days or last weeks, I've noticed more and more people are kind of seeing it as a way to create tech debt faster. And I think the knowledge of the people which have learned programming in an age where you didn't had an AI assistant just writing the working code for your exam for you might become a lot more valuable now, because it's for the newer generations it might be a lot harder and to put in the work when others are just can use the AI assistants to achieve the same. How do you find the motivation to actually walk the way, which others just take the AI bus, which gets you up the mountain too?
Well, it depends if you're studying for the grades or if you're studying to get better. And that's
Yes,
one thing that we have to do, I think, is develop a sense of pride. It's the same thing for many things in life. If you're proud of what you're doing, you're gonna be careful the way you write your text in prose. In our case, you're gonna use good French, good English, good German. You're gonna be careful about that. You're gonna be proud of the code you produce. You're right. You're gonna think about what you're doing. You're gonna be proud of the way you teach stuff. If you're proud, you want to be the owner of what you do. You want to be the one behind that. Even if you got help, you discuss with friends, you discuss with AI, that's cool. But in the end, it's you're responsible for it, and it's a matter of pride. So if you're in there for the grades, maybe do something else. I mean, there's other ways to make money. If you can hold your own, just gonna slow everyone down anyways.
true. Let's get back to audience question.
Mhm.
Will containers, mainly vector and string, use allocate at least?
I don't know, because that depends on their strategies. So I can tell you that I'm confident that if the library writers see a good opportunity for that, they will do that. But I don't know if they will. That's really on them. And they have these big test suits where they go way farther than we normally do because they test a lot of stuff we don't think about. So maybe they will see opportunities there where it makes a difference. I'm looking forward to seeing these things discussed in our reflectors for the standard, because that's always very interesting. See, I did this. There's an issue. There's a problem, and you can see the contours of the strengths and weaknesses of this. So we'll see. We'll see. I don't know. See. I'm looking forward to seeing more.
Yes. And then we actually have a question which goes a bit into the design of
Hmm.
containers. So
Oh,
Ian Potter asks, um, I'm trying to build my own vector where where I'm writing a hot cold split container where metadata is hot and data is cold. How would you structure access paths for performance?
that's a very interesting question. So Ariane, I'll tell you that it's hard to answer that in the abstract without seeing the code you're writing. It's an interesting question, though I would like to see the use cases. Uh, 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 One thing I could suggest, and since I don't know what your code looks like, so we're
Mhm.
looking at it from a broad perspective, is that your compiler is probably very good to figure out what you should do. So the optimizer is good these days. If you run tests, if you run benchmarks, and you notice that the decisions made by the compiler are not to your liking in some cases, so you think it's specifying things you would have optimized yourself, you can try to use the likely and unlikely attributes in your code paths that we add in C++ 20. But be careful, because as has been as I've been told by compiler writers already, these things they tend to go stale over time because compilers they always improve. So you have to reconsider your choices if you're trying to force likely or unlikely somewhere. So test often, test regularly, and redo your benchmarks regularly. You never know what's going on. It's kind of like when you're writing assembly code. I mean, it's cool. You have your C or C++ code basically. You're measuring, benchmarking, you're optimizing your stuff. Say, yes, I did good for this platform in assembly code. Cool. Keep your basic code close by because someday the compiler will make it faster than your assembly code. You're gonna want to go back to it. So, but if I saw your code, we could discuss it. But it's hard to discuss in the abstract. I can tell you it's a nice problem to work on.
Mhm. I see in the chat there's a suggestion to use an unordered map for this, and if you're like trying to have this more closer to a vector, maybe use something like a flat map or a flat. I don't know if we have a flat unordered map. We probably do.
We have
Um,
flat map, flat set. We know that at least.
and so that's probably like the wisest idea to when you want to have like the one part is like in the cache and the other part is cold. Then you cannot achieve that with an std vector because that is all contiguous in memory, and by definition you cannot have like one part of the container being somewhere else.
Yeah, if a Ariane goes that way, though, you have to know that the invalidation concerns of flat map and flat map, flat set, they're not the same as vectors, so the exception safety is not the same. So use tread there safely and read a bit on it before you start using them.
Yeah, where we at the point, again, that sometimes it's good to implement your own.
Mm-hmm. And publish your results. People we want to know about that. Publish a blog on this. It's gonna be interesting.
Yeah, of course. But let's get back to the book, which I do have a question about, like, how does a book then help you to get better with C++?
And that's a beautiful question. I think all books should get you there. I've been a reviewer on a few books in recent years, and sometimes I had books that told more about what you could do than and how you can do it than why you would do it. I hope my book is not like that because I appreciate myself. It's not because the book is bad. It's a good book too for something else. But I like when I read a book that it tells me why I'm doing things and helps me think about what I'm doing because the practice of reading is a transformative practice. You want to be a better programmer after that. So I'm hoping that the book gets you there. So your question is why or how does it make me write better code? I'm hoping that thinking about the basics first. So the first section of the book makes you reconsider maybe some of the things you took for granted in the language. We're trying to discuss what an address is, what a pointer is, the same thing, what an object is, and so on and so forth, alignment. Sometimes you knew that, but seeing that presented differently makes you rethink your stuff. I'm hoping that the automatic memory management section in the book makes you realize, if you hadn't done so, how important it is that the type system contributes to the safety of your code and to the clarification of the responsibility over the resources you're managing. I think that's essential. When the type system tells you what you're doing and helps you, you get very good leverage over optimization and safety after that, because safety is an important topic. Exception safety is present throughout the book. There's no chapter on it, it's everywhere because it's important. Regardless of whether you use exceptions or not, you have to think about that. I'm hoping that you will rethink the way you control things, allocators and stuff, and the way you see the object model, in fact. Because when you're writing operator new and delete, you get an in-depth view of the construction and destruction process of your objects. If you haven't thought about that before, you get a better idea of what the allocation means and where constructors and destructors come into play, what they do in your code, what role they play in your code. A constructor transforms raw memory into an object. A destructor does the reverse thing. It's not the same thing as allocation. What happens when why is it dangerous to throw an exception from a destructor? So if you read the book, you'll get there too. So I'm hoping you get the deeper insights as to what programming is with C++. And I think that should be something you can take to other languages too, in a sense, because you'll know why they do the things they do and why they made the choices they did. They're all good choices for their own domains. So yes, I think you'll get out of that book, not only with a better handle of memory management, but with a deeper understanding of what programming is in this language. that can only help you write better code, I think.
I think like we've already answered that question that you're part of the committee and that you've been in SG14, but I think it's probably like, a good time to ask like what in the context of the book, and we already had the question like what is new and what like what is coming, what is like ongoing with standardization regarding memory management.
We discussed trivial relocation and the new versions of new and delete earlier today. These are big things. C++23 has start lifetime as and start lifetime as array. So these are functions that intervene when you have a chunk of memory. You have all the bits right for objects, but they're not objects yet, in the sense that they haven't been constructed. But maybe you read the data from the network or from a file. You know that it's all correct, but the compiler doesn't know it's an object yet. So you would normally have to mem copy it into itself to create an object or something like that. There's tricks. But now we have functions that let you kind of bless the object into existence, which is for anyone who does low-level programming an incredible tool to work with. It's of course a sharp tool. You have to know what you're doing, but I think that can be considered to be something recent and important. The reflection C++26 will be transformative in so many ways. I was discussing in class yesterday and the day before with different groups of students the array of struct with respect to struct of array approaches to optimization, where you decompose objects into arrays of the data members because better for alignment, better for speed sometimes, and everything, but it's weird tricks. We will be able to kind of automate those things with reflection, transforming representations at compile time if we think it's a good thing to do. That's surely going to change the way in which we code. So I think reflection will be transformative for everyone. I'm hoping this is a correct answer. Is it more related to the work I actually do? We have pre-P2966, 2996. There's a paper of mine that's very big where we have requests incoming from the game industry and from SG14 in general. Lots of small papers in there. Some of them are making their way right now, and others will come too. So that is what is keeping me busy when I'm there. I'm trying to make a number of small things that together, as a whole, form a set of requests from the community for C++, and I'm hoping to move that thing forward for C++ 9.
All right. So I think we had a lot of questions, and it's a really interesting book. Actually, let me bring it up again.
Thank you.
So kind of going in reverse order now. There's 4 parts, and the whole book is actually covering not only the memory management itself, but also the context where basically this takes hold, which I think is really valuable. And Patrice is really a very knowledgeable person about this topic. So thank you for your time.
Thank you.
And you're welcome. And I see maybe there's like one last. Let's see if there is a. So yeah, I think there's an audience question which we can bring up. Final question. David
it's a big one.
Bellis asks, yeah, that's like that's like not bigger questions, right? I often
No,
pass
it's okay. Read it, but I know this.
raw pointers to child objects. This makes it easier to take advantage of runtime polymorphism. In the child object, I only use the raw pointer and only if it's not null. The overhead of a shared pointer is not necessary, as the parent object always lives longer than the child object, unlike in real life. What are your thoughts on this?
So yeah, thank you. So I'm glad that parents don't live longer than their children. I have 5 kids of my own, and I really don't want to live longer than them. I give them a long life. I am a recent granddad too. One of my kids had a daughter 2 months ago. So you're doing the right thing, David. Let's start from this. Smart pointers are about responsibility towards the pointee. So the idea of using a shared pointer, it's mostly important when you don't know where the last user of your pointee will be. If you know what it is, use a unique pointer instead. So when you're using a raw pointer, for years now, what been trying to convey in the standard is that most of the cases we're using raw pointers, you're not the owner of the thing, unless it's encapsulated in a container or something else. So when you're passing raw pointers around, you're essentially saying, use me, but you're not responsible. Don't try to do delete or something like that. In the book, yeah, I in the smart writing your own smart pointers section, I actually address this thing with two different types. One is the non-null pointer, which you will find versions of. Let's see in the GSL at Microsoft, they have something like that. So a type that by construction cannot be null. If you're trying to build it from something null, it will throw or assert or fail, whatever way you prefer. So you use the sort of type at the entry as an entry point to your public member functions thing. So when you get the pointer, you know by definition that it's not null, otherwise it wouldn't exist in the first place. So once it has passed that frontier and entered your code, just use a raw pointer underneath and use it because you're safe. So you don't have to test with an if. You know through the type that is correct. And if you want to move around a pointer that you're not responsible with and you're not comfortable with raw pointer, there's a proposal that has been flying around for a while called the dumbest smart pointer ever, and they call that the observer pointer. The name, people see the observer pattern there, so the name is hard to sell to people, but the idea is good. So the smart pointer that does nothing, but it's an object, so you cannot call delete on it. You won't destroy it by accident. If you really want to delete it, you have to make an effort, like do call .get and then delete on it or something like that. So you're using a smart pointer as an entry point to your functions. It costs you nothing, but you cannot accidentally delete it. It's a pointer. It's an object. So there's tools that you can use like that, that you can use as an entry point to your code. And once the object is inside and you know what it is, you know it's not null in your case, pass the raw pointer around. It's perfect. There's no problem. Raw pointer means you're not owning.
Yeah, so one particular thing bugs me in this question,
Aha!
and that is the mention of shared pointer. And I think I hope you covered in the book, because shared pointer is like not really loved by a lot of people which are more advanced in C++, for the very reason that brings me to the question, when I have this as an expert here, when should one use shared pointer?
But as I was saying, I think that okay, if one of the readers, or sorry, one of the tech reviewers of the book had questions about that too. He was disagreeing with me on a point. So my claim is that the 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 the, 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 the real reason why you have shared pointers is you have concurrency. Okay, if your code is linear and you know who the last owner of your pointee is, you don't need a shared pointer in general, except for very niche cases. So if you're doing that, because not only do you have threads that are using your object, you don't know which one will be the last. Because it's about responsibility again. If you know who the last user of your pointer is, a unique pointer is sufficient and it's lighter. So this is the one that's going to get your stuff away. If you have a manager, some people use singletons or something like that, and you have a manager of resources and everyone is using them all over the place, use raw pointers in your container. Use a unique pointer and make sure your container dies at the end, and that's fine. If you have two threads sharing a single pointee, and you know if A will die before B or B will die before A, then it's a shared pointer you need, because you want the last user to be the one responsible for that, and you don't know in advance which one it is. So of course there might be interesting cases that are escaping this discussion, but the key point there is this. It's not because you're sharing the thing that you want a shared pointer, it's because you want shared ownership, not knowing which one of the owners will be the last.
And yeah, I think that's one of the important things which I always think is that people often then forget that they do not only share the pointer, they share the context where the pointer is used. And that makes it a lot harder to have local reasoning on the code. That's why I think that shared pointer should really be used sparingly. And of course, there is a use case for it to do it. But especially if you can change the object which the pointer points to, and it's not a constant object, then you should be careful. And on the other side, for beginners, it's very tempting to use shared pointer because you don't have to care about moving it, and it's just copying itself everywhere, and it's fairly easy to use. And unless you get into cycles, it's just mostly lets you write code which works. At some point, you're going to find out it's not as fast as you thought, but that's like the other side.
Well, it's a heavy tool for specialized use cases, but for those use cases, we need it. So it's a useful type, but it's not the kind of type you use every day. It's a type for specific cases, and if you use them there, it's going to bring in results.
That is true. And with that, thank you for your time. I really enjoyed talking to you for this full hour. Seems to be a really interesting book. And so, any last words? Anything?
Well, first of all, thank you. It's been a nice chat. I haven't seen you in a while. I'm glad that you're there. And thanks everyone for asking questions and listening. And I hope you like the book.
I hope so too. And I'm looking forward to actually having it in the mail. It's on the way. It didn't work out, but I have the book from the last interview about C++, and that's also an interesting book, especially like if you're having a team, because it covers a lot of stuff which is not like interesting to the single programmer, but if you're in a team, that you probably have enough folks around that will find things in here. And generally, if you're interested in C++ and in the language, it's a great book to read.
Being interested in C++ is a good thing.
Oh, I think the audience is interested in C++. Well, thank you for your time. I'm going to take us offline now, and